Hello, everybody. This is a recorded video for Honors Pre-Calculus. We are looking at vectors and word problems. So start with this warm-up, give it a try, pause the video, and try the problem. Okay, I'm assuming that you have finished it. So dot product, remember that is the formulas right here, right? U1 times V1 plus U2 times V2. So the dot product of the first problem is 75, second is 4, and then third is 0. And this pair of vectors is the pair of vectors that is orthogonal because their dot product is 0. This was our last day of vectors. We're doing angle between two vectors just to show you again what the angle between two vectors formula looks like, what it includes, and we'll talk about some word problems. Here's the agenda. And again, all of these are in the slides in our MyMCPS classroom marking period 4, week 2 module with our resources page. So you can follow along in these slides there as well if you wish. Okay, so let's get into the angle between two vectors formula. So we talked last time about how it is a little bit like the law of cosines, right? How you find the angle with the law of cosines. So you need three things. You need the dot product between these two vectors, and you need their magnitudes. And then you arrange those elements accordingly, and then take the inverse cosine of that to get the angle between two vectors. So here's an example. We've got vector u at 5, 9 in the direction of 5, 9. We've got vector v in the direction of -5, 7. And I actually just have a little sketch of what these vectors look like. If you want, again, this is in the slides, it's linked, but Desmos has a lovely vector graphing tool. If you click on it, you can see, you can change the vectors if you want, right? You could change to, 2, 1. You could just see what they look like. And then you can click on, what the sum of the vectors is. If you subtract the vectors, what you get, what their dot product is. Look at that, isn't that cool? Magnitude of both vectors, super awesome. Let me pause the video for a sec.
So students who haven't had lunch, please make your way to the cafeteria.
Okay, so anyway, so these are the two vectors. So vector u is this green vector, vector v is this blue vector. So what we're trying to find is the angle between the green vector and the blue vector. Okay, so again, like I said, we need dot product, which I've color coded here in green. We need the magnitude of u, which I've color coded in this pink purple color. And then we need the magnitude of v, which I've color coded in light blue. All right, so we know how to find dot product now. We're great at it. Multiply the horizontal components, multiply the vertical components, add those products together, and we get 28. All right, magnitude of u, we also know how to find the magnitude of a vector, right? 5 squared plus 9 squared, square root that. I'm gonna leave it in the radical because I'm just going to pop it into this fraction later anyway. All right, so and then for vector v, same thing, same formula, magnitude. All right, so now I have my dot product, both magnitudes, and I'm just going to pop them into the formula like that. Inverse cosine of 28 over root 106 root 74. Make sure that you're in degree mode. So if I'm putting these numbers into the scientific calculator, you want to make sure, double check that you're in degree mode. So function inverse cosine, and then that dot product was 23, I believe. No, it was 28. 28. The struggle. Okay, 28. And then divided by square root of 106. Oops. See, you can see me mess up in the calculator. I'll fix it later. Square root of 74. 74, and then I'll delete this. All right, so there we go. I want to make sure I'm in degree mode because look what happens when I toggle over to radians. It's not right. The angle is not 1.2. It's 71.6 or thereabouts. Okay. And the reason I sketched them is so you could see 71.570, we round to 3 decimal places. Do you see? So that makes sense, kind of, right? If you look at the angle and you kind of orient yourself to the vector, 71.570 is a reasonable answer, okay? So if you were in radian mode and you saw that you got an answer of 1, that would not be reasonable, right? An angle of 1, you'd barely be able to see the difference between this daylight between the two vectors. So just use your reasoning skills, use your critical thinking skills when you do these sorts of problems. All right, so that is just a review, angle between two vectors. All right, we're going to talk a little bit about word problems. So vectors or angles in the direction of something. So which of the following vectors describes a runner with velocity 7 miles per hour acting in the direction of the vector -1, 1? And it's multiple choice here. Okay, so the way we would think through that, this is a vector with magnitude 7. The units are velocity, so the magnitude is 7. And -1, 1, if you think about like what that point is on the coordinate plane, it's in quadrant 2, right? It's kind of northwest of the origin, okay? And it's at a 135-degree angle, or you could say 45 degrees north of west, or a 45-degree reference angle, okay? So always in trig, we always think about, can we drop down an altitude to make that a right triangle and figure out the sides? Yes, we can, right? We just drop down a line perpendicular to the x-axis. We know that this is a 45-degree angle right here. And because this is a right angle, the other angle has to be 45 degrees because we're adding up to 180, right? So what this is asking about is basically what are the components of the vector, right? Each of these is a scalar multiple. These coefficients in front of the vector, you think about them as a scalar multiple, and then -1, 1 is each of the vectors that your vector is in the direction of, okay? So reviewing what we learned last quarter, a 90 triangle has these ratios for its sides, right? We have, if this was 1 and this was 1, this would be √2, right? This is just every sort of proportion of each side to the other side in a 90 triangle, okay? So what does that mean for 7, right? 7 in this case is the hypotenuse. So to get our components, instead of multiplying by √2, we have to divide by √2. So the components of this vector, this 7 mile per hour vector, 7 mile per hour magnitude vector are -7 over √2 and +7 over √2. Negative, because again, we're going left, we're in quadrant 2, the x's are negative because we're going left, and then the y component is positive because we're going up. You can check your work with the Pythagorean Theorem. Okay, so -7 over √2 squared plus 7 over √2 squared is 49, square root of 49 over 2 plus 49 over 2, so that's 49, which is 7, right? So our answer is C. So basically all we needed to do was divide 7 by √2. All we needed to do was divide 7 by √2 and just make sure we checked that we had that correct, x being negative and y being positive. Go ahead and try this one. Which of the following describes a person pushing an object up a slope with force 15 pounds acting in the direction of the vector 1, 1? So think about what quadrant 1, 1 is in, and think about what the sides of the triangle would be. Go ahead and pause the video, try the problem. All right, so the answer was B, right? We just divide by √2 because it's a 45, 45, 90 triangle. Positive, everything's positive because we're in quadrant 1, because the point 1, 1 is in quadrant 1. So the component form of this vector with force 15 pounds would be 15 over √2, 15 over √2, right? But since we only need to write it this way as a scalar multiple, we can say 15 over √2 times the vector in component form 1, 1. Okay, we're going to switch gears to word problems. So word problems, there are so many things you could do with word problems with vectors. We're going to limit it really to finding horizontal, vertical components and sums, and magnitude and direction. So these are all the tools we have at our disposal. Remember that magnitude cosine theta and magnitude sine theta find our vertical and horizontal components. And then we have these formulas below from our formula sheet on magnitude, direction, dot product, and angle. Okay, so I'm going to just do an example with you. We have two forces. They have magnitudes 20 and 30 pounds respectively. and they're acting on an object at point P. We're supposed to find the resultant vector F1 plus F2 in component form and its magnitude and direction. Okay, so I just color coded again, like with angle between two vectors. I'm color coding component form orange, magnitude purple, direction green. Okay, component form is the key to all of it. So if you remember, the way that we find a sum of vectors is by adding their x components and adding their y components, or their horizontal components and their vertical components. So let's look at F1, the 20-pound force in the 45-degree direction. The horizontal component would be 20 cosine 45, right? Magnitude, cosine, direction. So it's 14.42. The horizontal component of the blue vector F2, the other one we're adding, is 30 cosine 150. So that's negative 25.981. And it's okay that it's negative, right? Because if you think about it, from point P, it's going left and up. So it has a negative x, but a positive y, right? Okay, add those two horizontal components together and we get negative 11.839 is the horizontal component of the sum vector, F1, F2, and F1 plus F2. Okay. 20 for vertical components, we do the same thing, but with sine, and we end up with 29.142. Right? Add the vertical components of the add-end vectors together. So now that we have the x and y components of the new vector, it's relatively simple to calculate the magnitude and direction. We just use that distance formula with magnitude, right? 11.839 squared plus 29.142 squared, square root it, we get about 31.455 pounds. So the length of this new vector, the magnitude of f, this red vector, is 31.455 pounds. Tangent, remember the formula for tangent is, formula for direction is inverse tangent y over x. So our y is 29.142, our x is negative 11.839, and so we get negative 67.890. But that is in quadrant 4, right? Negative 67 is in quadrant 4, okay? So in this case, because we see that our red vector is pointing left and up, right? It's in quadrant 2, if you want to think about it that way. So we have to add 180. Okay, so if you get a quadrant 4 vector, like anything between 0 and negative 90, and you see that your vector is actually pointing northwest or terminating in quadrant 2 or going left and up, whichever way you want to think about it, add 180. So we get 112.110. Okay, this is something you could try if you want, but this is something we did in class, just breakout room jigsaw. If you want to take a look at it, basically every single group has a different question, and you can check the answers on the last slide if you want. All right, these are the assignments that are due. These are some other examples of word problems for your reference, just if you're curious or you want a few more examples. And then just in summary, vectors are used to model and predict many variables in the real world, including velocity and force. Being able to measure their components and their direction helps video game designers, aeronautical engineers, and many other scientists and professionals to predict and design a lot of the things that we use now. So thank you all so much for watching this video. I hope it helped, and as always, email me if you have any questions. Have a great one.